Okay, welcome to the third part of our lecture on short-term memory, and now we will talk about models, different models of short-term memory. Okay, let's start with so-called multi-store models, in particular one of them, which was proposed by Richard Atkinson and Richard Shiffrin in the late 1960s. And this is also called or known as the Atkinson Shiffrin model or the modal model. And it was a very influential model because it was a very early model in cognitive psychology for the human mind, for cognitive processing in general, not only on memory. Okay, let's have a look how that looks like. First, starting with an overview. It's basically a cognitive architecture which has three major stages. And the first one is that we receive input. Then this input generates cognitive processing, like with attention, short-term memory, things like that. And then some behavior is produced. So there's an output of the system. And this is pretty much as we can see that we perceive things, we process it, and then we respond to them in one way or the other. And in their model, memory stores are those places where the information is not only maintained but also processed. So they serve a dual purpose. In addition to the memory stores, they proposed that there are control processes which kind of regulate and control how the information flows between the different memory components, like short-term memory and long-term memory. Now let's go through that model step by step. So I will just show only the parts which we need for that. So in the beginning, we have the short-term store here, which holds and processes information in all modalities. So they assumed it's one store for visual, spatial, auditory information, verbal information, and so forth. Along with the findings of Miller, they proposed that the short-term memory span can span is about 7 items, so people can remember around 7 items in short-term memory. And they also proposed that you need to rehearse the information, otherwise it will decay and you will forget the information. Then they said there's also a long-term store, and the idea is, like we already discussed in the first part, that it holds all the information we have acquired through learning, and this information is stored permanently, and the capacity is basically assumed to be infinite, even if there are absolute limits for all purposes of everyday research and such models. It's usually fine to just say, yeah, it's an endless infinite capacity. And that's then the full model with the control processes included as well. So the control processes down here, they control the input to the short-term store. We see the sensory registers where we spoke about in the beginning, and they base their ideas also on the early selection model. So here the control processes could implement attentional filters to select which information gets into short-term store. But the control processes are also relevant for controlling whether information needs to be retrieved from long-term memory and loaded into short-term memory, so to say. And they also select what cognitive operations should be applied to the information here. Again, a very plain example might be mental arithmetics, and we may recall certain pre-known solutions and then work with those in here and do further things with the information. Although the model was very influential and for the time being really, really good, later research has shown that some assumptions are not correct, and this is just the way nature works. It's one of the first comprehensive cognitive architectures, so it needs to be revised. The first incorrect assumption is that short-term memory is modality independent. That means the same store for like auditory, visual, verbal, spatial information. And we know from later research, and we will speak about this in a moment, that there are at least two distinct subsystems for different types of information, one for verbal and one for visuospatial information. The second incorrect assumption is that Atkinson and Shiffrin assumed that short-term store is a single unit. So everything is in this unit. There's only one pool of resources, and if the resources are engaged by one process, they are not engaged in another process. So for instance, if I have to rehearse and maintain one bit of information, that uses up my resources and I can't spend them on other mental arithmetics or rehearsal of another bit of information or things like that. But we see from later research, again we will speak about this in a moment, that people are actually not too bad at doing two tasks at the same time, both requiring resources. And so that assumption seems to be incorrect as well. So in summary, short-term memory seems to be a little bit more complex than suggested by Atkinson and Shiffrin. Okay, so much for that model. If you have any specific questions, please post them in the relevant forum on BBL. Okay, so let's have a look at another type of model, the unitary store models, and I would like to present that rather briefly only. However, it gives you a good idea of how different you can approach such phenomena like short-term memory and how different the concepts and models can be. And this idea has been put forward by Nelson Cowan in the late 1980s, and the idea here is quite different. Namely, we only have a long-term store. We only have one store. We don't have separate short-term and separate long-term store, but instead we only have one store. Now, how can we have something like short-term memory, which we can see in behavioral experiments? And the idea is that all information is stored in the long-term store, and short-term memory is the information in the long-term store which is activated beyond a certain threshold. So you could say you have all the huge ocean of lingering, latently stored information, and now you activate some bits so that they peek out. And this is then the active portion of long-term memory and constitutes the short-term memory which we have. And then he further proposed that we can put our focus of attention on some very select items, and that is these are those items which are then cognitively processed. The idea is that external stimuli then get after the brief or from the brief sensory registers and after potential attentional filtering get encoded directly into the long-term memory store, and initially they may have only a rather weak representation, so that if they are not rehearsed and if it's not worked with, they are not necessarily staying in the long-term store for a long time. So it's not like that everything which we perceive and ever had in our short-term memory also would stay in long-term memory. It may be removed or decay rather quickly again before it's consolidated for a longer time. So, just to illustrate that you can find a completely different model to explain the fact that we seem to observe something like so different like short-term and long-term memory, different time scales and everything. Okay, the last model I would like to present for today is the working memory model by Baddeley and Hitch. I made the slides a while ago. I'm not sure these affiliations are still correct. So they, in the mid-1970s, basically replaced or updated the concept of a short-term store as proposed by Atkinson and Shiffrin in their modal model. And before we go into detail, I briefly touched upon this already. I would just want to make clear the distinction between short-term memory and working memory. So working memory is often abbreviated as WM. And it is still often used rather synonymously, so working memory in the sense of short-term memory, but mostly we would say, at least in psychology or cognitive psychology, sorry, that there are slightly different concepts. The idea is that short-term memory is just for the short-term storage of information. So if I tell you a phone number like 555-3421 and you want to keep that in your mind until you find something to write it down, this would be short-term memory, like the tasks we have discussed. Working memory, on the other hand, is also short-term storage of information, but in addition to that, the capacity or the ability to manipulate this information, so to work with it. And an example with a phone number would be, again, I tell you, oh, can you remember the phone number 555-3421? And while you're looking around to find something to write it on, I said, oh, sorry, I made a mistake. Please swap or switch the last two digits. So in your head, you have to perform the manipulation of changing 3421 to 3412 in your mind. And that would be an example of manipulation of information. And that would be the realm of working memory, this additional component, beyond the plain maintenance of information. Okay, so let's see what Baddeley and Hitch proposed as their model of working memory. And first of all, they proposed that they have a couple of different components which constitute short-term memory in the plain short-term memory sense. The first one is the phonological loop, and this is the short-term store for language and speech-based encoding, and it's kind of our inner voice. We will look into the phonological loop in a little bit more detail in a moment. So it's basically all verbal information. The second one is the visuospatial sketchpad, abbreviated often as VSSP. And that's a little bit like the inner eye, and it's visual and spatial coding. So, for instance, if you have object information. Then later in the year 2000, Baddeley added a third component, and he did that to account for new data which were hard to explain with just having the two components, which he termed the episodic buffer. And this episodic buffer holds and integrates information, not only from the phonological loop and the visual spatial sketchpad, but also, for instance, from long-term memory. And this episodic buffer can be used to create really holistic representations and memories, which bind together the auditory language speech-based information with the visual information with potential long-term information with that. And information can be exchanged between these buffers. Now, this is so far a short-term memory model, but Baddeley and Hitch also added what they called the Central Executive System, CES, to their model, and that makes it a working memory model. And they proposed that the Central Executive System, as the name suggests already, is kind of a supervisory system, which is first of all modality-free, so it's independent of whether the information is language or object-based. And another term which is often used is also like it's controlled attention. It can determine where to focus on, which information to keep in the store, which to transfer to long-term memory, which information to retrieve from long-term memory, and these things. So it controls the information flow between the buffers and also controls the buffers themselves. So, and this is also linked to these supervisory attentional system of Norman and Shallis, if you've heard of that. So what type of evidence was there, empirical evidence, to make them suggest this type of model? If you remember, they came from the starting place was the Atkinson and Shiffrin model, the modal model, where the short-term memory store is just a single store. And they made heavy use of so-called dual task paradigms. That means participants had to do two tasks at the same time. And just as an example, there are many studies of all different combinations, variations in the task and things like that. Let's say the primary task is short-term memory number recall. So you just present a set of 5, 6, 7, 8 numbers, and participants have to retain that for a while and then to recall that. And as the second task, they used many different tasks which were quite complex and resource demanding tasks. So this task was aimed at the phonological loop. And these tasks were aimed to occupy the central executive system. And this could be reasoning tasks, for instance. So participants were given a statement and they had to say whether the statement is correct or not. Other examples of such tasks which demand the central executive system is a random number generation task, which all you need to do is produce a sequence of numbers, just a continuous sequence, like one number per second, between 1 and 9 or so. And the only request is that this number sequence should be as random as possible. So you can't say 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, but it should be random. And for that you have to keep very good track of the past numbers you have seen to avoid obvious patterns to that. And that's a very simple but very demanding task, which also demands the executive system strongly. And Atkinson and Shiffrin in this instance would say, well, storage and rehearsal of information and the processing of information, like reasoning, demands the same resource. So these two tasks should heavily interfere with each other. So when you do them by themselves, you see a certain performance level, and if you put them together, people should really go down and much worse. However, Baddeley and Hitch found that both tasks can be done pretty good in parallel. Yes, you do see performance decrements to some extent, but not as much as would be expected if both would really rely on the same processes. So that's some finding which can't be explained by Atkinson and Shiffrin's model. And consequently, with a lot of different primary tasks as well, they concluded that the storage components, the phonological loop and the visual sketchpad, are separate from the processing component, the executive system. They are different. Along the same line, they used experiments to show that the two short-term memory systems, the phonological loop and the visuospatial sketchpad, are different as well. Again, as primary tasks, let's say it's a verbal short-term memory task, like number recall, which we just said, and as a secondary task, they used a visuospatial short-term memory task. And an example is the Corsi block task, which is also often used in the clinical setting. And in this task, when you look at the left side, the memorize, the experimenter and the participant sit in front of these spatially arranged cubes. Can be any arrangement, but it should be in a way so that participants need to remember the positions and can't easily verbalize that. And then the experimenter taps on the cubes in a certain sequence. Like first on the 1 denoted 1, then next on denoted on 2, then on 3, then on 4, then on 5. And this shading is just for illustration here, they all look the same. And then, either immediately or after a brief delay, participants have to repeat and recall the sequence by tapping the cubes in the same order, the blocks in the same order. And this is very hard to verbalize, so the assumption is that the Corsi block task taps into the visuospatial sketchpad. And again, same logic. If verbal and spatial tasks would rely on the same system, they should strongly interfere with each other. And again, Baddeley and Hitch did not observe such a strong interference. Yes, again, mild interference is there, but nothing so strong that they would say, yeah, it's two systems. So they have shown by this method of dual task approach that we have two distinct short-term memory systems. Okay, after having spoken about the idea that there's good evidence that central executive system, phonological loop, and the visual spaces sketchpad, and also episodic buffer are distinct components. Okay, my screen comes down, but let's hope it holds for the last couple of minutes. Let's look at the phonological loop in a little bit more detail. And there has been a lot of research going on for the phonological loop, and it's basically the short-term memory for speech-based information. And that's really a lot of our everyday life, which explains why there's so much interest in there. And follow-up research has shown that the phonological loop itself actually consists of two components. One is the phonological store, which holds items just passively online in an acoustic format. And the idea is that information decays rather rapidly, roughly around 2 seconds, if it's not refreshed. And then, as a second component, we have a rehearsal process. And this rehearsal process refreshes the memory's traces in the phonological store item by item. And if an item is not refreshed in time, it kind of falls out of the memory store, short-term memory store, and we forget it. And this is a little bit like these artists who do the spinning plates, and I would like to show this video. So the spinning plates here remember the items in our short-term memory store, and this guy is the rehearsal mechanism which has to reactivate each item in the short-term memory store. So he always has to give new activation, otherwise they would fall out, and the equivalent of that we forget them is the plate would fall down because he hasn't refreshed it quickly enough. So that's the idea of the distinction between having the items in memory and the rehearsal process. Okay, let's stop that. I think that's enough as an illustration of how that's going on. Okay, let's have a look at the visuospatial sketchpad as the other big component of the model, of the short-term component. And this is for visuospatial information, and it has been suggested that we have a capacity of around 3 to 4 items. So a little bit lower than for the verbal information or in the phonological loop. And again, rehearsal is required to prevent decay, and it has then later shown that the VSSP is divided into 2 subcomponents. One is the visual cache, which holds the information, and the other one is the inner scribe, which carries out cognitive operations. So, for instance, if you have to mentally rotate an object to see, oh, when I rotate it, does it fit in there? So, again, we have these type of two components. And yes, so a further finding from follow-up research is that information in the visual format, for instance, information about form, and in the spatial format are processed separately to some extent. Okay, if there are any questions on the concept of working memory and working memory or models in general, then just post them to the BBL discussion board. Okay, thanks a lot for listening, and then see you soon for the last part where we'll look at verbal short-term memory in a little bit more detail.